Hello, everyone. I'm Nick Morris, Deputy Director of Technology at NextFlex, and I'm here to provide some updates on our recent road mapping cycle and project call efforts. So, first, I want to say thank you to all the NextFlex members, government partners, everyone that have contributed to our 2025-2026 road mapping cycle over the last 9 months or so. This was a Herculean effort that we couldn't have done without you. So thank you all for your inputs, your refinement of the roadmaps, as well as the topics for the first part of Project Call 11, which is just now wrapping up. So if you're not familiar with our technical working groups, our road mapping cycle, our project call process, Innovation Days is a great opportunity to learn about that. So this slide shows some of the cycle that we do every year or so in terms of doing our road mapping cycle to identify state of the art, what different technologies, what are the states, what are the advances that have been made in different hybrid electronic print modalities or capabilities in terms of applications such as asset monitoring, automotive, sensing, communications, wearable and soft robotics. How has that advanced over the last year? And really focusing in on TRL, MRL 4 to 7. So where those manufacturing challenges and capabilities need to be demonstrated. We put those onto our roadmap. We leverage the subject matter experts to update the roadmap each year, focusing on the technical gaps, which was the real focus this year. And that leads into the project called topic generation, which we did at the beginning part of this calendar year, which led to the three topics in the first part of Project Call 11. We then take the proposals that we receive for that request for proposal, and then fund work for the community to do in advance the technologies and provide solutions to the gaps, the critical prioritized gaps that are identified by the community. So this is a cycle that we enter into every year. It's a very important, it's completely member driven in terms of identifying the challenges, providing the solutions, reviewing the proposals, and executing on them and sharing that information with the community. So it's hugely impactful to the industrial base, as well as our government partners that are looking to adopt the technologies. Just to give you a flavor of the timeline that's happened since about last October, the technical working groups formed of the subject matter experts from government, academia, and industry met several times to really drill down on the deep technical focus on the 11 groups that we run. We also held three cross-cutting technical working group meetings. So coming out of the individual groups that focus on specific technology areas, we held three meetings and invited all of the technical working groups members to attend, and those focused on two of the updated critical technology areas coming from the Office of the Undersecretary of War for Research and Engineering, which I'll talk about in the next slide. And then the third was, what are the enabling manufacturing technologies that continue to need maturation efforts and efforts to really advance them and have them ready for transition to a manufacturing floor. We also survey our technical working group members. That helps us get additional data points. So we're really looking at prioritizing the technical gaps so we understand when it comes to PC topic development, which we did earlier this year in March, we are focusing on the critical gaps that are really cross-cutting and impacting the most of our members and our government partners. We did publish the latest version of our roadmaps back at the end of March to coincide with the launch of the first part of Project Call 11, which you hopefully have participated in or have seen. We have now received the proposals for Part 1, Resiliency and Efficiency, and those are under review. We expect decisions on those very late July or early August. And we're now starting to gear up for topic development based on the updated roadmaps for our second part of Project Call 11, which we expect later this year. And don't have details yet on the number of topics, but the focus will be those roadmap inputs on trying to drive cross-cutting, high impact, solving those manufacturing challenges and demonstrating capabilities across the industrial base. So I just wanted to briefly talk about the critical technology areas, and this has been a big focus given that our funding is from the Department of War. There's a realignment back in the fall, going from 14 critical technology areas from the previous OUSW, R&E, CTO to now six really focused areas on what capabilities that are needed, what technologies are needed. what to be greatly accelerated to be adopted. And we discussed these across the technical working groups, across the roadmaps. Each roadmap now has a description of the alignment of those technologies with the CTAs that are applicable. But I really want to focus on contested logistics technologies, quantum and battlefield information dominance, and also scaled hypersonics. These are the ones that align best with at least what we believe hybrid electronics can provide capabilities, can provide solutions to be able to enable missions in these areas, such as point of need manufacturing, point of need repair, uh, swap constrained, so size, weight, and power constrained applications such as unmanned aerial systems, enabling communications, sensing for those types of platforms, as well as printed high temperature electronics for applications such as scaled hypersonics. So there's a lot of exciting alignment across the Department of War in identifying these technology areas, and we see a lot of opportunities for our community, our ecosystem, to really engage and make impacts in these areas. So back to the roadmap, I want to make sure everyone is aware. If you're a member of NextFlex, a tiered member of NextFlex, or a government partner, you have access to the full member benefit version of the roadmap. That's 11 different roadmaps, each about 10, 15, 20 pages. They vary slightly, but about 200 total pages of deep technical information. That's available on our member portal. We also have a public version of the roadmap, which takes each of those roadmaps and distills it down to a single page summary. And that has still very good information in terms of where a snapshot of what the state of the art is, where some of the key opportunities that we see and we share publicly, and gives you a flavor of the types of projects and the interest areas across our membership. Those public versions of the roadmap are available on our public website, nextflex.us. I just want to finally highlight some major updates to the roadmaps. Not just the structure, but the content themselves. We did a significant realignment of the technical gaps this year, making all 11 technical working groups have a much more defined and structured list of technical gaps. So this is 10 technical gaps. Each of those have about two sub gaps, all with measurable and quantifiable impacts. And this is all in the effort of identifying a need, but being as specific as we possibly can, which is driven by requirements for different applications, both in defense and commercial applications. And we made sure to align our 11 roadmaps and make sure that they are all driven by applications and use cases for adoption. So we have 6 groups that we call the TPDs. Those are technology platform demonstrators. All of the member benefit version roadmaps now have a transition targets table that clearly define domains within that technology area, potential stakeholders and stakeholders that are being engaged, what type of project called demonstrators need to be funded to demonstrate capabilities in those areas, and really aligning our community on solving these problems and demonstrating capabilities towards transitions. We also have 5 groups that we call the MTAs, or manufacturing thrust areas. Those are really focused on advancing, maturing the manufacturing technologies that are needed to enable those capabilities. And given those transition targets tables on the TPD groups, we directly align those to tables on our MTA groups that have application-driven alignment. So given a specific application for an antenna that needs to go on a swap-constrained platform and have certain capabilities, we can flow down what are the manufacturing requirements to be able to enable that, where are the gaps remaining to be able to demonstrate it, to scale it, to do qualification certification. And that's how that information flows down to the MTA groups and is represented on those roadmaps. So in short, the cross-cutting information flow is really critical from the subject matter experts across our ecosystem to us to help process that information and identify critical needs, but also across technical working groups. So we make sure that we're following a typical design or development process, from modeling the design through material selection, through what type of print modalities are going to use, assembly, device integration and packaging, and then what it takes to get something certified, what types of standards exist or need to be developed, and what type of testing and reliability demonstration needs to be done to show it's been sufficiently de-risked. And then making sure to flow down those requirements, or what enablers are needed across the different applications, like asset structural health monitoring, automotive, flexible power, wearable systems, integrated antennas, and soft and wearable robotics. So finally, I just want to highlight some of the major themes out of all these technical groups. First is the need for standardization and having shareable data across our community. Um, we've developed a significant amount and very rich data source over the last 10 years of project calls, 108 project calls, either completed or active to date, producing fantastic data that we share with the members. But how do we continue to utilize that data, make it more valuable, make it more usable and clear for our membership and our government partners as a resource of knowledge and know-how and data that we can share. So we're working on that. Qualifications and certification gaps. So as we move towards more mature technologies, the need to application specific qualification certification for that application is growing in need. And how we utilize that, how we standardize that and share those data packages is very important. Finally, continuing focus on sustainment, inspection, repair, aligning with the contested logistics CTA that I mentioned. How do we support our organic industrial base, our defense industrial base that supports sustainment of these platforms and electronics? And we have a number of options and opportunities there as well. I already mentioned the need to scale, demonstrate manufacturability, demonstrate quality, reliability, scalability, and it's incredibly important. And just in terms of an application standpoint, demand for higher power electronics, so printed electronics that can withstand higher currents, therefore higher temperatures, more robust for applications such as communications or power transfer opportunities in swap constrained, size, weight, and power constrained, aerospace, space platforms, unmanned systems, all growing more and more important and have unique technology demands. So if you'd like to learn more about these opportunities, we'd love to have discussions about the future and what we see and how we can continue to make an impact. So please join us for Innovation Day 2026. For more information, please go to our website, nextflex.us. Thank you.